Stepping onto an airplane is a routine part of modern life for millions. We trust the immense machinery, the skilled crew, and the unseen layers of safety that make air travel remarkably secure. Among the most recognizable aircraft in the world is the Boeing 737, a true workhorse of the skies, which has carried passengers safely for decades. It's a design that has continually evolved, adapting to new technologies and demands, promising greater efficiency and comfort for travelers worldwide. But even the most trusted designs can face unforeseen challenges, leading to moments of profound uncertainty. The Boeing 737 MAX was introduced as the latest iteration of this successful aircraft family. Its primary goal was to offer significant fuel efficiency improvements and increased range, making it more economical for airlines to operate and providing more direct routes for passengers. To achieve this, Boeing equipped the MAX with larger, more fuel-efficient engines. These engines, however, changed the aircraft's aerodynamic characteristics, meaning how it behaves in the air. This necessitated a new system to ensure the MAX felt familiar and handled similarly to previous 737 models for pilots. For over half a century, the Boeing 737 has been a pillar of commercial aviation. From its first flight in 1967, it quickly became the best-selling jetliner in history, connecting cities and cultures across the globe. Airlines around the world relied on its robust design and operational flexibility. Passengers saw it as a safe and dependable way to reach their destinations. This deep-rooted trust, built over decades of reliable service, made the introduction of the 737 MAX seem like a natural and progressive step forward for air travel, promising continued excellence. On October 29, 2018, tragedy struck. Lion Air Flight 610, a 737 MAX 8, crashed into the Java Sea shortly after takeoff, claiming 189 lives. Initial investigations focused on maintenance issues and flight control problems. This incident immediately raised serious questions, not just for the airline, but for the entire aviation community. It was a stark reminder of the immense responsibilities involved in air travel. Experts began to scrutinize every detail, searching for answers, as the world watched with heavy hearts, hoping to understand what had gone so terribly wrong. Just 5 months later, on March 10, 2019, another 737 MAX, Ethiopian Airlines Flight 302, crashed 6 minutes after takeoff from Addis Ababa, killing all 157 people on board. The similarities to the Lion Air crash were chillingly apparent. Both planes experienced erratic flight paths, struggled with pitch control, and plummeted to the ground. This second disaster eliminated any doubt that there was a systemic issue. The aviation world reacted with profound alarm, demanding immediate action to prevent further loss of life and to uncover the root cause of these devastating failures. The common link between these tragedies was a system called MCAS, or Maneuvering Characteristics Augmentation System. MCAS was designed to automatically push the aircraft's nose down under specific conditions. Remember those larger engines we talked about? They were placed further forward on the wing, which could, in some situations, cause the plane's nose to pitch up more than desired during certain maneuvers. MCAS was meant to counteract this tendency, making the MAX handle consistently with previous 737 models. It was supposed to be a background system, rarely activating, and unseen by pilots. At the heart of MCAS's malfunction was the angle of attack, or AOA, sensor. This sensor measures the angle between the wing and the oncoming air. Imagine holding your hand out of a car window. If you tilt it up, you feel more lift. That's a higher angle of attack. The AOA sensor provides crucial data to the flight computer, indicating if the plane is approaching a stall, which is when the wings lose lift. The problem was that MCAS relied on input from only one of these sensors, and if that single sensor provided erroneous data, the system would activate incorrectly. The critical flaw was how MCAS used the AOA sensor data. If a single AOA sensor failed or sent incorrect information, MCAS would repeatedly activate, pushing the plane's nose down. This happened even if the aircraft wasn't actually in danger of stalling. Pilots in both fatal crashes found themselves fighting against an automated system that was erroneously commanding the plane downwards. It was a terrifying scenario. The system designed to enhance safety became a direct threat, pushing the aircraft into a dive that pilots, without full knowledge of the system's behavior, struggled to counter. Following the second crash, and despite Boeing's initial confidence in the aircraft, the global aviation community acted swiftly and decisively. Country after country, led by China and eventually the United States Federal Aviation Administration, or FAA, issued emergency orders to ground all 737 MAX aircraft. This was an unprecedented move, affecting hundreds of planes and causing immense disruption to airlines worldwide. The grounding signaled a collective commitment to prioritize safety above all else, ensuring that no more lives would be lost until the root cause was fully understood and thoroughly fixed. With the planes grounded, a comprehensive and intensive investigation began. Aviation authorities, accident investigators, engineers, and pilots from around the world scrutinized every aspect of the 737 MAX design, software, and certification process. They painstakingly analyzed flight data recorders, or black boxes, from the crashed aircraft, ran countless simulations, and conducted extensive test flights. This was not just about fixing a bug, it was about understanding how a critical safety system could fail so catastrophically and ensuring such an oversight could never happen again. The core of the fix involved significant software updates to the MCOS system. Instead of relying on a single AOA sensor, MCOS now takes input from both sensors. If they disagree significantly, MCOS is disabled. Furthermore, MCOS will only activate once per event and will never repeatedly push the nose down. Crucially, pilots now have the ability to override MCOS at any time, restoring full manual control. These changes fundamentally altered MCOS from a potentially dangerous hidden system into a robust, supervised aid that enhances safety rather than jeopardizing it. Beyond the software fix, a crucial component of the MAX return to service was enhanced pilot training. Pilots flying the 737 MAX now undergo comprehensive training modules specific to the updated MCOS system and other flight control scenarios. This includes extensive simulator time, where they practice recognizing and responding to even highly improbable malfunctions. The goal is not just to teach them about the fixes, but to instill a deep understanding of the aircraft's systems and robust procedures, ensuring they are prepared for any situation and can always maintain full command of the aircraft. Bringing the 737 MAX back to the skies required a rigorous recertification process by aviation authorities worldwide. This wasn't a rubber stamp, it involved months of painstaking reviews, test flights, and validation by independent experts. Regulators like the FAA, EASA, European Union Aviation Safety Agency, and others conducted their own analyses, ensuring every proposed change fully addressed the identified safety deficiencies. This global, independent scrutiny ensured that the MAX wouldn't fly again until it met the absolute highest standards of airworthiness and safety, restoring public and regulatory confidence. Following recertification, the 737 MAX didn't immediately return to full operation globally. Instead, its return was phased, with individual countries and regions granting approval based on their own comprehensive reviews. Brazil and the United States were among the first in late 2020, with others, like Europe and Canada, following in early 2021, and China much later. This gradual approach allowed airlines to implement the changes, conduct their pilot training, and bring their fleets back online cautiously, reflecting the careful and measured restoration of confidence across the international aviation community. So, what does all this mean for you, the passenger, today? The 737 MAX has undergone one of the most intense safety reviews in aviation history. Every aircraft has received the mandatory software updates, and every pilot flying the MAX has completed the enhanced training. The scrutiny applied to this aircraft has arguably made it one of the most thoroughly examined and tested planes in the sky. This extensive process, driven by the tragic lessons learned, aims to ensure that passengers can fly on the 737 MAX with the highest possible level of confidence in its safety. Pilots are often the most direct guardians of passenger safety. Today, pilots flying the 737 MAX are not just trained, they are intimately familiar with the updated systems and procedures. Airlines have invested significantly in ensuring their flight crews are fully prepared. This level of confidence comes from rigorous training, clear documentation of all changes, and a fundamental shift in how MCOS operates. Knowing that multiple layers of protection are in place and that they have full command means pilots can operate the MAX with the same assurance as any other aircraft in their fleet. If you're curious about the aircraft type for your upcoming flight, there are a few simple ways to check. Most airline booking websites and apps will display the aircraft type once you've selected your flight. Look for details like Boeing 737 MAX 8 or B738 MAX. Flight tracking apps, like FlightAware or FlightRadar 24, also provide real-time aircraft information once your flight number is known. Knowing your aircraft type is simply about being informed, not about generating concern, as all currently flying 737 MAX aircraft adhere to the strictest safety standards. While aviation authorities have certified the 737 MAX as safe, some passengers might still feel a personal apprehension. It's important to know that you always have the right to be informed. If you discover your flight is on a 737 MAX and you feel uncomfortable, you can contact your airline to inquire about alternatives. Some airlines, in an effort to be transparent and reassure passengers, even offer the option to change flights. Ultimately, the decision to fly on any particular aircraft is personal, but rest assured, the experts have done their work to make the MAX safe. The scrutiny of the 737 MAX didn't end with its recertification. Aviation safety is a dynamic field, constantly evolving. There's ongoing oversight by regulators and airlines, with continuous monitoring of the aircraft's performance. Boeing itself has committed to greater transparency and improved safety processes. This vigilance ensures that lessons learned from the MAX incidents continue to inform future aircraft designs and operational procedures. The entire aviation industry understands the critical importance of maintaining public trust through unwavering dedication to safety. The challenging journey of the 737 MAX has, paradoxically, led to a stronger, more robust global aviation safety system. It exposed vulnerabilities, prompted deep reforms in certification processes, and reinforced the need for independent regulatory oversight. While the human cost was immeasurable, the industry has responded with an unparalleled commitment to preventing such tragedies from ever recurring. This experience has instilled a deeper culture of safety across design, manufacturing, and operation, benefiting all aircraft and ensuring that flying remains the safest mode of long-distance transportation. In conclusion, the story of the 737 MAX is a complex one, marked by tragedy, intensive investigation, and ultimately, comprehensive solutions. For you, the passenger, the crucial takeaway is that the aircraft has been thoroughly vetted and significantly improved. The systems are updated, pilots are highly trained, and regulatory oversight is more stringent than ever. When you step aboard a 737 MAX today, you are flying on an aircraft that has been subjected to an unprecedented level of scrutiny, with every effort made to ensure your journey is safe and secure. Fly confidently, knowing the skies are safer than ever.